Morning. My name is Mark Fike. I'm a software engineer at Internet 2. I'm also a member of the perfSONAR development team. And this morning, we're going to talk about a scripting language called JQ and how it fits in with perfSONAR. I have 2 hours scheduled for the meeting today. I don't anticipate it's going to take that long. The material should probably take an hour and 10 to an hour and 15, and that will leave us plenty of time for questions and answers and so forth at the end. If you do have a question, please either use the raise your hand feature here in Zoom. It's under participants, or paste something into the group chat. I have that up in a window here, so I should be able to see when people have questions. So I'd like to begin just by warning you that some of what I'm going to cover today is kind of considered advanced material. Most of what I'm going to cover here applies to administrators of perfSONAR rather than end users. There are a few places where this would be useful to end users. And having said that, JQ in itself is a very useful tool in its own right if you have JSON data to process. It is available on the command line as well. So even if you're not administering perfSONAR, this is still kind of a useful bit of information for you to have. So today we're going to cover 3 things. We're going to cover very briefly what JSON is and how it works. We're going to spend a bunch of time covering the basics of the JQ language. And we're going to spend some time discussing how it's applied inside of perfSONAR. This material is kind of foundational for future workshops. There will be other workshops in the future on how to use archivers and how to use the limit system and so forth. And some of the features of those figure prominently into both of those. So let's dive into JSON and talk about it. This is a very short subject. Actually, it's only just a couple of slides. JSON is the JavaScript Object Notation, and it is a lightweight text-based way of exchanging data. Its structure is based on constructs from JavaScript, but it is independent of languages. And the 2 things that kind of make it really attractive to use is that, number 1, it's easy for humans to read and write, and it's equally easy for machines to parse and generate. There is an established standard for it. It's called ECMA 404. You can download the standard, the whole standard off the internet. Or actually, pretty much everything you need to know is on one page at json.org. It is really that simple a format. In one slide, a blob of JSON is a value, and it's one value at the top level, and then others, any place another value is called for. So if you take a look on the left here, you see there are basically 6 different things that can be values. At the top, there's some simple things like strings, numbers. You can do integers, floating point, positive, negative. There's a Boolean type, so you can say true or false. There is a null type, which is actually just one value, null. And there are a couple of compound types, arrays, which are lists of values. So you can do a list of strings or a list of objects or a list of mixed types. Similarly, there's also an object, which is a group of key value pairs. So you'd have things that you can look up by name and don't have any particular order to them. The way this is set up, you can make these things as embedded or as recursive as you want. You can make very simple data structures. You can make very large, very complex data structures. It's just all in what you put in it. Nothing is particularly type checked. So you can have values that are anything you want, and however you want to use them is considered okay. Here are just a few examples of what pieces of JSON would look like. Down the left-hand column, you have a string, you have an integer, you have a Boolean value of true, you have the null value. Down at the bottom, you have an array of integers, 3713, 6264, and 9411. And on the right, you have a couple examples of objects. And these are actually pretty intuitive as to what they are. You have pairs that you look up. The thing on the left side of the colon is the key. So in the first example, you have a make and a model for keys. And if you were to ask your JSON parser for the value of model, for example, you would get PU238 out of the first one. The second example on the lower half of the right side is a little more complex. This has an ID that's an integer, and it has a sub-object called inventory that itself has a few things in it, like quantity and a list of shelves that maybe that item sits on. So it's fairly straightforward there. If you've done other things like HTML or XML or anything else like that, in some ways it sort of has the same sort of embedded recursive structure to it. So that's all I have to say about JSON. I'll take a pause between major sections here for questions if anyone has one. Okay, well, hearing none, we'll plow forward and take a look at JQ. The best way I can describe JQ is to steal the author's words, because he kind of said it best. And JQ is a lightweight, flexible command line JSON processor. It gives you kind of the same sort of programmability and flexibility to do things sorts of things with JSON that you do with text using sed, awk, and grep, and those sort of things that you're all familiar with for using on the Unix command line. If I had to pick one of these tools that I think JQ is closest to, I would probably say awk, but even in that case, there are still some areas where they're vastly dissimilar. But it is sort of in the same vein. There's plenty of documentation available. It's all on Steve Dolan's website, which is stevedolan.github.io/JQ. You'll find a tutorial, you'll find a manual, you'll find downloads for the source, and I think a few binary formats as well. This is available on a lot of Linux distributions. I know on anything derived from Red Hat, it's just called JQ. perfSONAR uses version 1.5 of JQ. I point this out because the documentation on the website is actually for the development version. There is a link you have to use to go to the kind of current production version. So be careful of that, because there are a few things in the development version that have been added since 1.5 was released. And once we get to 1.6 or whatever the next version is, we'll probably upgrade to use that as well. So JQ has basically two major modes of operation. In both of them, you start with some JSON as input, and you pass that through a thing called a filter. Now, the filter can be operated in one of two modes, either in regular mode, where the output that it produces is also JSON, and this is kind of the 95% use case, or you can use it in what's called raw mode. And what that means is that instead of outputting JSON, the filter outputs plain text. And I'll show you an example of how this works in a future slide. There are some additional switches you can flip on it, but this is probably the one that you're going to care about most. And as I said, 95% of the time you're in regular JSON mode anyway, and using it raw is just sort of an odd case that you might find you need once in a while. If you want to experiment with JQ, you can invoke it on the command line. You just say JQ. You give it some options, and there is help available for that. Excuse me. You provide a filter, and optionally, like most Unix command line tools, you provide either a file, or if you don't provide that, it will simply read its input from the standard input. As a JSON description, and this is something that we have in pscheduler and the upcoming PS config, we have a little blob of JSON that we call a transform, which is how you describe something that you do with JQ inside of either package. And the way that works is you just have an object called most places it's called a transform, and it has in it an item called script that has the filter in it, which is the script or the program that you're going to use. And there's another optional thing to turn on to turn the raw mode on and off, and I'll show you that in a little more detail in a bit. Additionally, if you don't want to install JQ or you just want to experiment with it, there's a great website called jqplay.org where you can put in a filter and some data to work on and press the button and get the result. And you can see there are some additional switches up at the top there. This is kind of a handy thing as a debugging tool to when you're working on filters and kind of getting the hang of it, because you can sort of play with it interactively and don't have to stuff what you're doing all the way into perfSONAR and try it out and see if it works. So strongly advise if you're learning this, spend some time playing with JQ Play, because it will help you get there a little faster. So let's talk about filters, which are sort of the meat of what makes JQ work. This has sort of been covered in a previous slide, but I'll cover it again anyway. Every JQ expression is a filter. We'll talk about what the expressions look like in a bit. And a filter's job is to take input and produce output. It's pretty much the same thing that you would do with grep or or sed or anything else like that if you're doing things on the command line. But this is sort of the basic tenet for everything in JQ, is that anything you deal with in JQ takes input and produces output. So that's just something to keep in the back of your head as we go forward here. Probably the simplest filter on the planet is a constant, which can be any valid piece of JSON. And in this case, input is ignored unless the constant uses it. More on that later. But in this case, here's just an integer constant that ignores its input and it produces itself as the output. So your filter is just the constant 86, and the output that it produces is itself. So it's the integer 86. JQ has functions built in, which either come in the form of bare words or in the kind of more common notation that you see, where you have a function with arguments, as you might when you're writing programs in other languages. There are a very large number of built-ins, and these are all very nicely documented in the manual. There is also a way to define your own functions, which I'm not going to cover here because it's a slightly more advanced topic. And that's handy if you have something that you want to use repeatedly within your larger script. But again, the model for those is pretty much the same. A function takes input, does something with it, and produces output. A lot of what you'll do with JQ is extraction of values from the input. And this is probably the smallest valid JQ script there is, which is a dot. Now in JQ, the dot is what's called the identity operator, and what it refers to is all of the input for the filter. It's not particularly useful by itself, other than perhaps as a pretty printer. You can take a piece of unformatted JSON and run it through JQ dot, and because JQ pretty prints by default on the output, that's what you'll get as a result. It is, however, a starting point for lots of other filters that do things with the input. Here's a very simple example of that. We'll start with an array that has just 4 integers in it, 13, 24, 86, 99. And we will use the bracket operator, which might be familiar from other programming languages for pulling things out of arrays, to say, I'd like element number 2, please. Element number 2 is actually the third element because the indexes are 0-based. So the output of this filter is the result of the extraction. So in this case, we've picked out element number 2, and we get 86 out of it. The rest of the input is dropped on the floor because there's sort of no alternative place to put it. You can also do slices if you want to take a little piece of an array. You put the lower and higher ends of the range you want in the bracket separated by a colon. So for example, if we go for 0 through 2, we get an array out that says 13, 24, and 86. One thing that's important to note here is that the expression that goes in the brackets can be any valid JQ filter itself, as long as it produces a non-negative integer. And this is actually true for pretty much any expression in JQ. You could actually put a fairly complex expression in there, and as long as it produces something that the brackets can use to extract an item from the array, it's good. In this case, I just did something really simple. We just did some basic arithmetic. I said 1 plus 2, which adds up to 3, and we get 99 out of that because it's the number 3 element in the array. Similarly, you can use the same operator to extract values from objects. In this case, we have an object that has two pairs in it called A and B, and in the middle of the filter that we use, we extract the A element from it, and we get 86 out of that. And again, as with arrays, the expression that you put inside the brackets can be any valid JQ filter that produces the type that we're looking for. In this case, it's a string because that's how items and objects are keyed. You can do, here's an example of that. You can do much more complex things. Here's some things where we use a little bit of nesting. We've added a K field to our object. And we use a filter. We pull out the K field, and we use that to name what we're going to pull out. So we pull out the K, that becomes a string of B. The B is put back into the object, and it says, okay, we're going to pull out the B pair, and we get 99 out of that. So again, that's same principle, just applied nested. Additionally, as is the case with most programming languages, expressions are evaluated from the inside out. There is a shorthand for doing this, so you don't have to type all the brackets and strings and so forth. If you have things that look like identifiers, which in most languages is A to Z, uppercase and lowercase, 0 through 9, and the underscore, you can simply say dot and the name of the field you want to pull out. So similarly to what we did a couple of slides ago, here we just pull out the A pair just by using dot and the name of the name of the pair. Anything else, if you have other characters that do not fit that model, you can just put quotes around them. So for example, if you had something called agent-number, the hyphen obviously is not going to be valid there, and you just take that and put it in quotes. This is only for objects. You can't use this with arrays, largely because, for example, .2 is a numeric constant, and that will confuse the heck out of JQ, and it will throw an error and complain if you try to do that. Some extensions to the shorthand. You can basically take these and keep doing them, much like you do in a lot of other programming languages. In this case, we have a slightly more complex object on the left that has a sub-object called A, and it has an X and a Y, and Y is an array. So essentially what happens here is the filter that you see in the middle just traverses down through through what's there, and it says dot A, pulls that out, the dot becomes what it pulled out of dot A, or what it pulled out of A, and then we do the same thing with Y, and we extract the 0th element from it, and we get 1. All the same rules I've talked about before apply as far as what goes in the brackets and what the and how you would extract the pairs out of the object. When what you're looking for is not there, JQ will simply give you a null for the value. So here's the same object that we looked at in the last slide, and I'm getting .r.h9 out of it. Well, none of that exists, so JQ simply returns a null for it. Null never results in true when used with comparison operators. So if you're trying to pluck something out and see if it's greater than something else, then that's never going to evaluate as true. The exception is when you're doing comparisons against null itself. So in this case, if we were to say if we were doing a comparison to see if this is null, obviously you'd get a true there because null versus null and null versus not null are valid comparisons. In this case, when the expression that you're trying to pull out is not right, JQ will throw up its hands and say you can't do that. So in this case, again, same object, but we're trying to pull .a.x 0, and JQ will complain about that because 3.8 is a number, it's not an array, and therefore won't be happy with you about it. One other thing you can do, and this kind of falls under the headings of making constants, you can build your own. And so in this case, I'm going to give as input to the script one of the objects that we've kind of messed with in prior slides, where we have two pairs. A is 86 and B is 99, and we have a script that builds up as a constant a piece of JSON. So perhaps we have a pair called agency that's always the value control, but we create a pair called agent, and we extract the B element out of the input to create that. So the output that you get out of that is agency is control, agent is 99. I'm going to take a quick pause here for questions. There's one from Yvonne, which I will hold, I think, until after we're through. When we're talking about this in terms of where it applies to perfSONAR.
Probably it's even internal, I'm sure, because
yeah, no, we do handle it, and I will answer the question toward the end.
Thanks.
Sure. Okay, so let's talk a little bit about more complex topics, namely pipelines and lists. One of the neat things you can do, and of course, if you've done shell programming, you've seen this before. But one of the neat things that you can do with JQ is called pipelining. And what it allows you to do is take some input, apply a filter to it, take the output of that filter, pass it through as input to another filter, and produce output. Again, it's pretty much the same thing as you would do with the shell with the pipe. Pipelines can be arbitrarily long, so it doesn't matter how many filters you stack up, and it's all pretty much the same model. That entire pipeline is itself considered one big filter. So, for example, here's a fairly simple pipeline where we get input. It's a string. It's the chief. And the script that I show you here, the first line is actually the script, and the subsequent lines are just sort of what it turns into, sort of how JQ thinks about it internally. So the first thing that we do is we pass the string, we pass the input through the length function, which for strings in JQ returns the number of characters. So in this case, that length evaluates to 9. 9 becomes the output of that and is passed as input to the second filter in the pipeline, which is an arithmetic expression where we take the input, 9 in this case, we divide it by 2, and we get 4.5. The output of that, 4.5, gets passed through to a built-in function called floor, which just takes the next lowest integer, so the output of this is 4. So it's, again, much like doing things with shell scripts, it's pretty straightforward. You can sort of think of the dot as what came in on standard in if you want to apply that model to it. The other thing that you can do with JQ, and this is where things get really interesting, is making lists. JQ has an operator which is a comma, which is a little like the pipeline, except that the filters that you provide between the commas all run in parallel, and each one sees the input. And that happens, as I said, that happens in parallel. What this produces is a thing called a list, which is a little different from an array. But each item in the list is the output of one of the filters. And one of JQ's kind of little dirty secrets is that all the input and output are actually these lists, and I'll talk in a second about how lists work. But all of JQ's input and output is actually done with lists. The thing of it is a lot of times if your input is just one blob of JSON, it's a list of one thing, but you might use this operator or some of the others to split it into other things. And I will refer to that implicit list as the list. So here's a really simple short script that makes a list, and you can see I'm just doing 3 constants that are separated by commas. So I have 86, 99, 13, and that produces a list 86, 99, 13. You can't have these lists in the input because they're not valid JSON. It's also worth pointing out that the list is also not a JSON array. It's just sort of this amorphous list that JQ passes around in between filter items. Where lists get interesting is what you can do with them in terms of things like pipelines. So we'll take the script that we did in the last slide, and we'll add a pipeline to it. So we'll take our 86, 99, 13, and we'll pipe it through an arithmetic expression that adds 1 to each element in it. When you have a list, what the pipe operator does is it actually applies what's in the pipe or what's on the other side of the pipe to everything in the list. So in this case, you actually get back a list of 3 items, each of which are the input lists items having been incremented. So we get 87, 100, and 14. Now that's not particularly useful when you get to the output, but I do want to stop and mention that when you do an array constant, it actually uses this concept. So for example, if your script is or if your filter is a constant array, in this case 86, 99, 13, you put the brackets around it, and that just converts that list into an array. So it's sort of a thing that looks like a constant, but you're actually doing something with a list and producing a JSON array as a result of it. Now, because you have to have valid JSON as input, obviously you probably want to have a way to break an array up into a list so you can do things with it. So in this case, I've taken our same array and I've converted that into, I've made that the input. And it's a very short script that just takes the input and it uses the brackets with nothing in them. And what that does is that takes every element of an incoming array and it breaks it out into the list. So what that means is that the next thing that, if you were to pass this through to something else, and I'll show you this in a second, but the next thing that gets this would get this list of 86, 99, and 13. Here's a little application of that, pretty much the same thing that we've shown in previous slides. We have our array as input. We, on the left side of the pipe, we split it into the list, and on the right side of the pipe, we increment everything, and we get pretty much the same thing I showed you 2 slides ago, just with the JSON array as input, as opposed to writing a constant. This works for objects as well. If you apply this operator to an object, what you'll get back is the values in the object. So in this case, we have a name, we have an organization, and when you pull that apart into a list, what you get are sig, freed, and chaos, which are the values. There's also a built-in function called keys that does pretty much the same thing, except that it outputs its output is a list of the object's keys instead of its values. As I mentioned before, you can make an array from the list just by putting brackets around it. So in this case, we have the example that we had before, where we took a list of integers, added 1 to them, and converted the result into an array. So essentially, we've taken the internal list, the list, and we've turned it into a valid JSON array that can become part of the output. You have to be really careful where you put your brackets, because the way JQ works, everything in the list is treated separately. So if you put the brackets around the wrong place, as I did here, for example, I put it around the arithmetic operation, what you would actually get out of this is a list of 3 very small arrays. And this is just because what's on the right side of the pipe is invoked once for each item in the list. So that's something to keep in the back of your head. You can, of course, because anything in a list is itself a valid filter, you can make a list from the input. So in this case, we have an input of 5, which is just an integer. And for each item in the list that we create here with the commas, we multiply by 2, we get 10. We add 3, we get 8. We divide by 5, we get 1. So I guess what I'm trying to point out here is that dot, or the input to the filter, is available to all the filters when you use a parallel operation with the commas. I'm going to take a quick pause for questions if anyone has any. Let's see. Well, yes, actually. Grant Skipper asked the question: will breaking out an array of objects result in a list of objects? And the answer to your question is yes, it will. An array is really just a list of, or I should say it's an array. I would say an array is an array, but it sounds kind of funny that way. But when you break it out, whatever the elements of the array are get broken out into the list. So if you had an array of objects, or if you had an array of an object and a string and an integer, those 3 things would come out into the list, and that's what would be processed next.
I have a question. If I pipe several filters, the dot, what was that? Dot identifier. The dot. Oh. I'm not sure how you code it, but would the dot take the input, the initial input, or it will be if I use the dot in between the filters, would the dot be the initial input, or it will be the one that is evaluated at the moment, until the moment we reach the internal?
Yeah, the dot is the dot is whatever the input to the current filter was. And as I start to show you some more complex examples, you'll see why you'll see why this is. But in this case, for example, what I have up on the screen now is just a very simple example where we have input of of an integer, and we just do some simple things to it. If you're doing more complex things to it, for example, let's say that on the right, instead of just dividing by 5, we pipe that through floor. What would happen is that in itself is kind of a little sub-filter. So what happens is 5 becomes the input to that part of the of what you're doing between the commas, and then you divide by 5. The output of that becomes the input to the floor that you use that you use afterward. So it's usually best. It's usually best to put these things into into parentheses to group them. You can do that as well. Does that answer your question?
Yeah.
Okay, cool. We have a question from Tao Zhang, which says he has an input that's an array of 1, 2, 3, 4, 5, 6, so integers, and his filter is extracting elements 1 through 3. The elements in that are exclusive. So if you actually the output of that because these are zero based, the output would actually be 2, 3, 4 because the first element is element 0. Okay, hearing no other questions, I'll show you some additional interesting things we can make JQ do for you. One useful thing you can do is making changes to the input on the fly. So in this case, here's an object that we take as input. So we just have an agent of 86, and we have a name of Max. And let's say that we need to add our task at hand is that we're going to add an organization to it, which will be control, and we also want to convert the name to uppercase. So the script to do that would start out keeping in mind that the input is what comes into this in the first place. We simply do an assignment. So we say, in this case, we say .org equals control. So after that first part of the that first part of the pipeline, the output of the assignment operator that you see in the first line would be the input plus whatever change was applied. So in this case, we added something, and we just simply said it's control. So the output of that gets piped through to the next thing, where we take the name and we use this pipe equal operator, and what that says is just take the value. This is a lot like the plus equals and minus equals operators that you find in other languages. But what the pipe equal operator says is take the right-hand side and treat that as a filter. So you could actually do something more complex in there. In this case, I just took it and pushed it through a built-in function called ASCII upcase that converts it to all uppercase. So the output of this, what you end up with at the end, is agent 86, which has not been changed. You get name is uppercase Max because we've converted everything in that string to uppercase, and we get what we added, org equals control. So anytime you make a change, the remainder of the input stays intact and just gets passed through, other than what you changed, of course, and just gets passed through to the next piece of the pipeline. JQ also has a notion of a variable, and the way those work is also as part of a pipeline. So in this case, we have the array that we've been playing with previously, and the first thing that we do in our script is we use what's called the as operator. And what that does, the as operator evaluates what's on the left side of it. In this case, we're just going to take the input, we're going to pipe it through length, so we know how many elements there are in the array. And on the right side is the name of a variable. In this case, it's just going to be count. The output of the as operator is just the input. It passes it through. So the process here is that the expression on the left side of as is evaluated. JQ makes a note that it's going to be stored in a variable called count, and it just spits the input right back out. So the next piece of the pipeline here uses a built-in function called add, which for arrays of numbers produces a sum. And then we take the result of that and we divide it by count, which was the variable that we stored. So essentially, this is just a way to take the average of a set of numbers in an array. And in this case, we get 56. The variable, once you've created it, is available to all filters that follow it in the same pipeline. In this case, we're just doing the whole script as one thing. So it's in that respect, it's fairly straightforward. But if you're doing a pipeline as, say, a sub-expression and something else, then that variable would be available just inside of that pipeline.
Shouldn't the output have been 66?
You know what? You can check my math on that if you want, Sean, but you might be right.
Just wanted to make sure I was following.
Yeah. Let us know, and if I goofed, I'll correct it. I have a sneaking suspicion that I ran this before I played it. But.
It's 66.
Ah, okay. Well, then I get an F in math for the day. So something else you can do that's really useful is making decisions, and you do that with the if statement. And it is much like everything else. It is a pipeline operator. It takes input, does things with it, and produces output. So in this case, we have a little piece of input that's an object, and we have a size that's 34.6. We have a weight that's 24.1. So we take the if operator and we do a comparison here. We have what looks like a fairly complex expression on the inside. It's not really. Essentially, we take size. If you go all the way into the center of it, sort of the deepest part of it, we're extracting size. We're piping that through floor. We take the result of that. We use the mod operator to figure out if it's even or odd. And if it is even, then we produce a string that's even. Otherwise, we produce a string that's odd. Now, what you have after the if and after the else can be, again, any valid JQ pipeline or any other filter. So you can do very complex things in there if you want to. One thing that's really important to note here is that because these things are all filters, they have to produce something. So what that means is that you can't have an if statement that does not have an else, because you have to produce something. If you have an if statement where you don't need an else condition, the thing that you would do is just your else clause would simply be a dot, which would take the input and pass it through to the next thing. One other thing that's useful to do is you can do interpolation inside of strings, and that's useful for taking things out of your input and making them into strings. And in this case, you can see we have the backslash and a set of parents. What goes inside the set of parents is, again, any valid JQ filter. So in this case, I've simply taken a couple of things. I've extracted a couple of things from the input to produce the final string, which is Maxwell Smart Agent 86. I could have done something like divided the number by 2 or converted the name to uppercase or anything else like that. So again, any valid bit of JQ you can stuff inside those parents, and the result will be converted to a string and substituted in its place. So those are sort of the basics. There is actually a lot more. We're sort of scratching the surface here. I would strongly recommend, if you're going to use JQ, spend a half an hour, go dig through the documentation to sort of see what things are there. There are all sorts of neat things. You can do loop structures, recursion. They have sort of a primitive version of map and reduce. There's a whole library of math functions. You can do interesting things with regular expressions. There is a try and catch mechanism so that your scripts can try things and catch problems and react to them accordingly if you want them to. And as I mentioned, there's also a way to define your own user-defined functions, and there's also a mechanism for having libraries and so forth. We have a question from Tao Zhang about whether or not the floor function works for negative numbers. You have to look that up in the documentation. It probably would. My guess is, and it's just not something that I've really had a need to go look up, but my guess is that it probably uses the underlying function in the C math library, so it probably behaves exactly the same way. So now that we've sort of covered the language itself, I'm going to take another short break here and see if anyone else has any questions. Let's see, built-in count. Let's see. Okay, the count, the $ count was actually a variable that I set. The question was from Grant Skipper. It's, does the built-in $ count only work from the top level? For example, if you have an object that has agents and IDs that are arrays 1, 2, 3, 2, 3, 4. No, I think the built-in that you're looking for is length, and that will work anywhere. So if for example you want to extract the number of IDs, you would say .IDs to pull the IDs out of your JSON object, and then take that and pipe it through the length built-in function, and that would evaluate to an integer. And you can take that, and any place you need a valid JQ expression, you can put a complex filter. So you can do those sorts of things. There are a few odd cases, and I'll cover one of them a little later. There are a few odd cases where you may need things from earlier input in a context where you can't see them, and that's a good place to stuff those things into variables. Okay. So now here's where we talk about where we use JQ and perfSONAR. JQ turned out to be a really good fit for perfSONAR because almost all of the data that's handled by pscheduler and the upcoming PS config traverses the system as JSON. And in the process of adding some additional features, just some things that we did during development, we discovered that there were several places where it would be really convenient to add a hook to make changes or to make decisions about things. And JQ, it turned out, was a really handy way to do that because it adds a whole lot of end user programmability without the end user having to make changes to the system, which we're trying to avoid because we'd like all these kind of fancy, powerful features to be available in the stock version of perfSONAR. And additionally, they don't have to write custom plugins. One of the first places I used this, actually, I'll cover that in a second. One of the first places I used this was in a feature where I looked at something and I said, you know, if people really just have to do simple changes to their JSON, it would be nice if they didn't have to write a custom plugin. I'll show you where that is in a minute. As I mentioned very early on in the presentation, we have sort of a standard format for the transform. It's a little blob of JSON that we call a transform, and it has 2 items in it. It has a script, which is a string that represents the script, and it has an optional pair called output raw, which by default is false. If you turn that on, what you'll get is what's in the list at the end of the filter will be output line by line instead of as JSON. When we release perfSONAR 4.1, there's going to be a slight change to the standard transform. This is going to be optional, so you can actually either do it the old way or this way. You can also specify the script as an array of strings, which it turns out is a lot easier to edit and read and so forth. What happens is internally when you're using this, each one of the items in the array just gets all of them get joined together with new lines into one big string. So that's something to look out for in 4.1. Will make things lots easier to read. One other thing you need to be aware of, because all of this is usually encased in JSON, is that you're expressing the contents of your scripts as JSON strings. And what that means is that you have to watch out for characters that are treated specially by JSON that have to be properly escaped. The 2 that you're going to worry about are quotation marks and backslashes, because inside of JSON strings, those have special meaning. So in this case, here's a plain JQ script that just generates a string. You're going to see this in a future example. And I have the things that are special characters that would be interpreted specially by JSON highlighted in red, so you can see the quotes around the entire string, and the backslashes for doing interpolation into the string would have special meaning. So in order to make that work inside of an actual JSON string, you have to do what you see at the bottom. You take the entire thing, you enclose it in quotes because that's what JSON requires, and then the places where you have special characters, you simply escape them with a backslash. So your quotes become backslash quote, and your backslashes become double backslash. In the production code of this is all part of pscheduler, but in the production code that we shipped with perfSONAR 4.0.2, there are 3 places you can use JQ. The first is in the transformation of run results before they're passed to archivers for sending off for other processing and storage. The second thing is part of the limit system, where we convert downloaded lists of CIDR blocks from a JSON format to new line delimited plain text. And the third thing is making decisions about whether or not a requested task meets the constraints of a limit that you want to set up. So I'm going to cover each of these in some detail. Some of these will become part of other kind of short subject workshops on various parts of pscheduler and perfSONAR. So the first thing we're going to look at is transformation of archiver input. I'm gonna pick on Sean for a minute because he was actually sort of the impetus for doing this. His project Pundit has had a need to do special conversion of some of his output to another format that would be sent off to his systems for processing. So what we did was we built in this thing that will allow when you're doing an archiver, you'd be able to convert it to whatever format you need. So in this case, we have a task at hand. We're just going to say we're going to take an archive result. We're going to format a string from it that just contains what type of test was run, what tool was used, and what the duration of it was. Maybe it's an informational thing. And we're just going to send that to syslog, and we're going to stick the runlog identifier on it. And perhaps this is for a system that just keeps track of what it runs, and maybe they have Splunk or something else like that that's picking those things apart. So I will apologize in advance if this is too small to read. I don't think it is. We kind of did a test run with this the other week. But this big, huge blob of JSON that you see here is the input to the archiver. Now, if you're not doing a transform, if you're using, say, the syslog archiver, this big blob of JSON will be sent directly to syslog without any changes to it, which might be useful, might not in some cases. But in this case, there are three things in here that I've highlighted in bold type that we are interested in. The first is the type of the test. So you kind of traverse your way down into the test pair, and that has a type in it. It's a string called trace. We're interested in the duration, which comes out of the schedule, and we're interested in the name of the tool that ran it. So that's under tool. That would be like .tool.name. The actual result ends up is on the right. We actually don't care about anything that was in that. But if you were doing other things, maybe you just run a bandwidth test and you want to pull out the average calculated bandwidth and just pass that someplace. This would be a way you could do that. So inside of archivers, and I'm gonna explain this whole blob of JSON here because this is a subject that's not familiar to a lot of people. But pscheduler has a thing called archivers where you can send the results of your test runs to one or more places. So the first thing that we do this is called an archive specification. We tell it what archiver to use. In this case, we're going to say use the syslog archiver. There are a handful of these, probably 5 or 6 that we ship with the system. It is plugin based, so there's actually ways to write additional ones. The syslog archiver has an archiver specific blob of data that comes with it. In this case, it's the 3 things that you would give to syslog if you were sending something to syslog. So in this case, we have an identifier called ident, we have a facility, and a priority. And you can see in the ident, we set that to runlog because that's kind of what our task at hand said that we were going to do. The next thing in the specification is the transform. Now, as I mentioned a second ago, this is entirely optional. So if this is not present, then that entire blob of JSON that we looked at on the last slide would be sent straight to syslog, and that would be the end of it. But in this case, we're going to apply a transform to it. We're going to take the JSON that came in, we're going to pass it through JQ with a little bit of script to do the formatting that we want. And this, what you see here would look a little like what I showed you a couple of slides ago when I was talking about how to specially escape things. So in this case, we said ran. We pull out .test.type, which pulls out that string that has the test type in it. Width, of course, is just constant. We pull out the tool name, and we pull out the duration that was in the schedule. Now, in this case, because we're producing a string, all we want to do is just produce the string. We don't want it to be a JSON string with quotes around it because that's going to look kind of funny if you put it into the system logs. So in this case, we flip the output raw switch, and we set that to true. So the output of this pipeline will be a JSON string, and JQ will look at that and go, oh, I need to strip the quotes off the end and turn it into just a regular plain string with nothing that hints that it's JSON. Worth pointing out here, the transformation happens before the archiver sees the result. So this is all done inside a pscheduler, and what the archiver gets will be would in this case be the formatted result. You can use this for other things. For example, if maybe we have an archiver that sends things to RabbitMQ, and perhaps you have some different form of JSON that your system on the other end of your RabbitMQ expects to see. you can do those sorts of transforms right here. And it all becomes part of the specification of what you archive, rather than having to write a special plugin and convince people that they should install it on their systems. So this is what the result looks like. This is what the result would look like in syslog after it was done with. So we have timestamp, host name, and we have runlog, which is our identifier, and you get the string. Now, had we not done the transform, just to kind of beat a dead horse here, had we not done the transform, the syslog entry would consist of the entire JSON as it came in. So, so this is a way to kind of trim out the things that you don't want, or do things to add value to it, that sort of thing. So the next thing we're going to use is part of pscheduler's limit system, and our task at hand in this case is that we want to use the limit system to identify requesting hosts that are part of Amazon Web Services. As it happens, Amazon makes this list available in JSON format, and it's downloadable at the URL I have there in the middle. There's documentation if you want to understand what's inside of it. Put that in there mostly just for reference. But what we care about is this list. The limit system has an identifier called IP CIDR list URL, and this is in a lot of ways is sort of parallel if you're used to using BWCTL's limit system, where you were generating limit config based perhaps on some things that ESNet had available. For example, they make available a set of data that's a list of all the CIDR blocks that are believed to be R&E. This is a way to automate the process of doing that, so that you can set your limit file up to say, get that data from somewhere else, and not have to have an external program that takes care of doing it. So what this identifier does is it periodically downloads a list of CIDRs from URL. It refreshes it periodically, and it identifies incoming requests that originate within those blocks. The format that it expects is just a simple list of IPv4 and IPv6 CIDRs separated by new lines. So you can see down at the bottom here, we've got a couple of v4s and a couple of v6s. Nothing fancy to it. It's not JSON or anything else. It's just CIDR, new line, and so on. This is a very small subset of what we might get back from AWS. I put some fictitious blocks in there. And the things that we actually care about are in the two sections called prefixes and IPv6 prefixes. I probably would have designed this file a little differently, but it is what it is, and it is what we have to work with. So in this case, in order to pluck out all of the prefixes and just convert them into a list, we know that we need to go through every item in the prefixes array and pluck out the IP prefix item. Similarly, for IPv6, we need to do the same thing. We need IPv6 prefixes, everything in there, and we need the IPv6 prefix for each object in that array. So the way you would do that with JQ is actually fairly straightforward. We're using the comma because we want to feed the input into both things and have them each produce something a little different. So on the left side of the comma, we have a thing that uses a construct I haven't showed you yet. In this case, this just says dot prefixes and the empty brackets, which you have seen. What this does, if you use it in the shorthand format, this is the equivalent of taking prefixes, splitting it out into a list, and then applying, and then for each item in that list, pulling out the IP prefix item. So you can see in the raw output on the left, we have the IPv4 prefixes that would have pulled out this 192 block and the 198 block that are in the first two lines. We do a similar thing on the right side of the comma, and that again gets a full copy of the input to the filter. So we pull out everything in IPv6 prefixes, and then for each item in that, we pull out the IPv6 prefix pair, and that gets you the additional two IPv6 prefixes that you see down at the bottom of the list. So the way you would use this in the limit configuration, and again, this is part of pscheduler, this is also going to be the subject of a future workshop. So I'll explain the entire thing. You give the thing a name, so we're going to say this identifier is AWS. We give it a description, which is just readability for humans. We give it a type, which is IP cited list URL. And then inside of that big blob of data are things that are specific to that type of identifier. So in this case, the things that identifier requires are a source, which is where the URL goes that you're gonna download the list from. You give it a transform, and again, this is optional. So for example, if you're downloading the data from ESNet, they provide the data already in the format we need, which is just new line separated, new line separated values. I see a question about the last slide from Tao again. I'll answer that. What he asks is whether or not the brackets are necessary in the thing on the left side, and I guess the right side as well, of the expression there. The answer to your question is yes. The brackets are necessary because otherwise, if you just say prefixes, the kind of output of that, what that would evaluate to is the array. And what you really want JQ to do here is to take the array, break it up into the list, and then for each item in the list, extract the IP prefix. Let me go back up to the block list here. So because the prefixes thing has more than one thing in it, you want JQ to operate on each item in it, and that's what the empty brackets get you. So I hope that answers your question. Anyway, so in this case, we have a transform, and this is just the same script that we saw previously. Additionally, we have output raw turned on because we just want a list of plain values. We don't want it as JSON. We have a few things down the bottom. We have an update interval. P1D is updated once a day. Retry is PT 4 hours, which just says if you don't have, if you were unable to download last time you came up to download it, try again every 4 hours. There's an exclude list, which just weeds out some prefixes we don't like. And then we have this fail state thing, which is false. And what the fail state is, that just says that if for some reason, if either the script fails, if the JQ script fails, or if we have not yet been able to successfully download the list, then don't identify as AWS. So what that means is, if let's say for some reason Amazon is having a huge outage and it's before we've downloaded our first copy of the list, any requester that we look at this, we're not going to say yes, it's AWS, because we actually really don't know. And this is just set up so that you can set it to true if you actually don't care and you want to err on that side of the fence. So I do apologize. Some of this is probably new material to a lot of you, and I will be doing some workshops in the future that will cover some of this in a little more detail. Okay, so the next item is making decisions about limits. So let's say, for example, we have a local policy that says that we will not do trace tests that have a hops parameter of any more than 20. So if somebody comes in and asks us for 50, we're going to tell them to get lost. If they come in and ask us for 12, that's fine. We'll do that. The way we do this is through a transform, and we interpret the output. We have kind of a special interpretation of the output. So the transform is, and I'll explain in the next slide how this all fits in a little more detail. But essentially, the transform that you're going to build for this has to produce one of three things. It has to produce a Boolean value, so true or false, and the value would be true if the task that's being proposed is okay. You would produce false if it's not, or if it's not okay, and you want to produce a diagnostic message that would get passed in and put in with the information that the people can look at to figure out what went wrong. You can do that as well. So in this case, you might produce a string that says traces must be 20 or fewer hops. This is a test specification. This is something that gets handed off to that would get handed off to the transform. Down at the bottom, if you started using pscheduler, on the command line down the bottom is the equivalent command line that would have generated this. pscheduler actually only ever works in JSON, and the the task command in pscheduler is actually just a nice way to generate the JSON using command line options. So these two are pretty much the same. But in this case, the specification is for a trace test, and the destination is ps.example.edu, which we actually don't care about, but we do care about the number of hops that are in there, because this guy has asked for 50, and that's more than we like. So this is kind of a new style limit specification. If you're doing this in the current system, you would have to do it. You'd have to do it as a single string. It's a little more readable this way, so I went with the new style. So in this case, we have a limit that's named trace hops, and we have a description, and it has a special type of JQ, which is just we make a decision using JQ as opposed to doing something else. So the data for this is the transform, and our script is just actually a couple of things with a little pipeline. The first thing that we do is we take the value 20 and we store that in the max hops variable. And the reason that we do that is that it's going to get used in a couple more places further down, and it's much easier to define it in one place. And it also makes the things further down the script a little more symbolic and easy to understand. So we take the input, because as doesn't really do anything other than set the variable and pass the input through, and we pass it through this if statement. So the condition in this if statement is compound. So we check and see if the type that was provided as part of the test specification is trace, and we check to see if the hops value as part of the specification is greater than max hops, or 20 in this case. Now, if it's if there was no hops value provided, that's going to come up null, because as I explained before, if you ask for something that's not there, you get a null back. And null, of course, will never be greater than 20, so that's okay. So in the example I showed you in the previous slide, if someone asked for 50 and was asking for a trace, this would come out true, because the type is trace, the number of hops is 50, and that's greater than our maximum. So what we produce in that case is a string that says traces have to be max hops or fewer. And otherwise, we just produce a true, because the thing is okay as was specified. So these are the three things that are available right now in the production code. I'll take a quick pause for questions and to take a drink.
I have a question. Can I pipeline, or how can I combine multiple?
Yvonne, if that's you, I think your microphone is pointed the wrong way.
Okay. Yes. Okay. So can I put multiple of these
yes.
specifications?
Yes.
So, and they will be processed one after the other.
Yeah. That's the order that these specs get processed is or how they get processed is fodder for a whole different workshop. But yeah, you can build as many of these as you like. You can make all sorts of you can make the scripts as complex as you like. Anything that you can do with the incoming JSON that's valid JQ, you can do these sorts of things. Oh, this is actually probably a good time to answer your question about what happens if there's an error in the script. In this case, let's say I don't know. Let's say let's see. If there's a syntax error in it, then the limit system wouldn't get initialized, and you get a diagnostic about that. But for example, if it throws a problem at runtime, in this case, it's going to be treated as having said false because there was a problem. So what will happen is you'll actually get in the diagnostics, you'll get a diagnostic message that said this didn't pass, and here's why, and the reason will be that there was a runtime error in the script. Let's see. I have a question from June. Let's see. Maybe this is mentioned. Yes, there will be a recorded version of this and the slides available after we're finished. I will be providing that to our training guys, who will put it up someplace. That way I don't have to do this again. Not that I haven't enjoyed it. Okay, so let's press on, and we'll talk about what's coming in future releases. We have 3 new things coming in 4.1 that involve JQ. One is called task rewriting, the other is called priorities, and the other is part of psconfig, which is a new thing that also has a spot where you can do transforms as well. So we'll talk about those. And for anyone who's wondering, there's about 83 slides here, so we are getting into the home stretch. So let's talk first about the task rewriter. And this came about largely because of something I had to put together to make bandwidth limitations work in the first version of pScheduler that I thought was kind of a hack and didn't really like. But in this case, the task at hand is that local policy is we want to limit bandwidth of throughput tests to 50 megabits per second when there's no bandwidth parameter supplied, which, as I'm sure if you've used iPerf, implies go as fast as you can. And when the requester has not been identified as part of a classifier called friendlies. In other words, if the requester is not somebody that we like, and he's either told us go as fast as you want, or he's given us a number that's greater than that 50 megabits per second, we want to say, nope, you're getting clamped to 50, whether you liked it or not. So the transform that we use to do this actually takes the task specification and it modifies it in place. So I'm gonna bypass showing you the task specification because it's going to look actually pretty similar to the one that we did in the last example. So inside of the limit configuration will be a new thing called rewrite, a new section called rewrite, which is one big it's one big JQ script, and you can put lots of things in here to do all sorts of different comparisons. There will be a fairly comprehensive example shipped with it that will show you some things to do. I might write a little cookbook because there's some neat things you can do with it as well. But in this case, we'll just concentrate on this one simple example. And we'll start out, as we did before, by setting a variable called maxBW to 50 million, because we're going to use that in a couple of places elsewhere. So we take what comes in and we pass it through a slightly more, an if statement with a slightly more complex condition attached to it. In this case, we pick out, we want to see if the test type is throughput and the test spec bandwidth is not there. Actually, I take that back. I think what I said in the previous slide is not true. We're not capping it. We're just setting it to 50 megabits if it's not there. And you can use other limits to say you can't do this if you want to go faster than 50. But the other thing that's different, there are a couple of things in here that are underlined, and these are some functions that are provided by pScheduler as part of the rewrite feature. So the first one is called classifiers has, and there is actually an underscore in there, but the underlining sort of obliterated it. And what that does is that just returns a Boolean value. You give it a string that says, I want to see if, in this case, friendlies is in the classifier, and it returns true or false if the friendlies classification has been made of the requester. Now in this case, we want to invert that, so we pipe it through a built-in function called not, which does pretty much what it sounds like. If the input was true, it produces false, and so forth. And if it was false, it produces true. Now, interesting to point out here again, the expression of the parents where we use classifiers has is itself a full JQ filter. So you could actually throw ifs or anything else you want in there. You can make those expressions as complex as you like. I've found in playing with this that you really don't need to get too complex with a lot of these things, and if you do, you can pull them out into a separate function, which makes things a little more readable. Anyway, so if all these conditions are true, then we take the test spec and we assign a bandwidth value of maxBW, and we take that and we pipe it through a function called change, which just emits a diagnostic that says, hey, I throttled the bandwidth to 50 megabits. Hope that's okay, because that's what we're doing. Otherwise, if those conditions above are not met, then the else clause just passes the input through unmodified, so you get the exact same task out as came in. So what will happen with this? In this case, this is the diagnostics. If you go look at the diagnostics for a task, you'll see some of this. But in this case, if you look at who was classified, we just got the default classifier, which is something that's applied to everybody. That's something you'll see, and you can actually see that now in the current version of the limits file that we ship with the toolkit. And what will happen is, if the rewriter makes any changes that it wishes to mention, those diagnostics will show up as well. So in this case, you can see that where we called change, it emits this this diagnostic that says, hey, we throttled the bandwidth to 50 million. On the right side, you can also see some of the additional diagnostics. And in this case, I just really put this there just to show that when we ran iPerf, which is what happened to run that test, the bandwidth was limited to 50 megabits. So it just sort of shows that the whole process works. Something that is we're probably about 90% of the way there with this. It has some rough edges that I'm in the midst of taking care of as we speak. Is a system for prioritizing measurements. Priorities in the future version of pscheduler, again, this is slated for 4.1. We should, I think this should get out with that release. But priorities are just integers where if something has a higher value, it gets higher preference. Nominally, we use 0 for neutral. That's not anything that's required. You can use whatever scheme you like. So in this case, let's say we have a local policy that everybody starts with the lower or the default of, the lower of either the default priority, which let's say is 0, or the priority that they requested. So if they requested -50 because they really don't care if their measurement runs or not, we'll start with the lower of that. Our second policy is that anybody we consider friendly gets a free 5-point bonus. And the third policy is that we give a certain group of explicitly allowed requesters the leeway to set any priority they want above 0. So other than the 5-point bonus in the second bullet, this is actually in a lot of ways sort of parallels what Unix does. If you're going to use nice, you can always tell the system, yeah, give me less priority, but you have to be in a special group to say I want higher priority. Now in this case, the transform that we're going to use to do this uses, again, some specially provided functions, and I'll point those out as we hit them, to manipulate the priority, and the output is discarded. We actually don't care what comes out of it. So in the limit system, there'll be a priority section, which has in it, again, one big script. And in this case, this is the script that implements the things that I described in the last slide. So the first 2 lines of it, you can see we call set, which again has an underscore. That's something that's built in. And inside of that, the parameter that we give it, sets the priority to an absolute value. So in this case, we build an array of default and requested, and we pipe that through the built-in. This is a JQ built-in called min that just takes the contents of the array and finds the smallest one. And we pipe that through change, which just emits a thing that says, all right, we set the initial priority. The second section, which is the bottom half of the left side, we check and see if the classifiers has friendlies. So if we consider this requester a friendly person, this is exactly the same function that I showed you before with the rewriter. And if that's the case, then we give them their 5-point bonus. We call this specially provided function called adjust that takes an integer that adds it to whatever the current priority is. So for example, if we started with a priority of 0, because that was the default, if our requester is friendly, we adjust it by 5, so he ends up at 5. And of course, the else for that is just a dot. We do nothing. We pass the input through to whatever the next thing is. Finally, on the right side, we take a look and see if the classifiers has the priority positive classifier, which might be something that we set up to say, maybe we'll let some of our close partners or people on the local network set high priority if they want to. So in this case, if that classifier has been met and they have requested something that is higher than the current priority, then we set what they requested and we emit a diagnostic. Otherwise, if none of that's true, we just pass the thing through and fall out the bottom. So I'll show you a few quick scenarios about how this works. If you have a random requester who asks for high priority, you can see that his classification was just default, so he doesn't get any special treatment. We don't consider him friendly, and we don't consider him one of the people that we let set high priority. And the way the script that I just showed you works is it would just set the initial priority, and that would be the end of it. And that requester would get a priority of 0, or nominally the default. Similarly, here's same situation, just different classifications. In this case, this is a friendly high priority requester who asks for no special priority. And you can see that he's been classified as both friendly and priority positive. So what comes out of the prioritization process is we set the initial priority to 0. We gave him his 5-point bonus because he's friendly, but he didn't ask for anything above 0, so we leave it at that. So he gets a priority of 5 just because he happens to get a bonus because we like him. Here's the same situation, except that the requester has asked for a priority of 20 instead. Same deal here again. He's priority positive and he's friendly. So we start with the initial priority of 0. We give him his 5-point bonus. Now, had he asked for a priority of 3, we would say, well, okay, but we've given you 5, so we're going to set your priority to 5. But since the priority he asked for was 20, which is greater than where we were, we give him that instead. He gets a priority of 20. Finally, something new, and I'm sure probably Andy will talk about this at some point, is in more detail at some point, is psconfig. psconfig is a replacement for the existing meshconfig software that does pretty much the same job, but it has a lot more power to it. One of meshconfig's big deficiencies, and this is the reason it's being replaced, is that it was really built for a different era, and in order to take advantage of any of the flexibility that pscheduler offers, every time somebody writes a plugin, we would have to rewrite meshconfig, and that sort of limits the things that meshconfig can support. So Andy came up with a whole new architecture for that called psconfig, where you can define things like hosts and groups of hosts and tasks and schedules and archivers. And the thing that's important is the tests that you run and the archivers that you use will all interoperate properly with pscheduler, so that we don't have to change psconfig anytime somebody writes a new plugin or we add a new test to the system using that mechanism. So one of the places that the psconfig uses this, it might be the place, is that after the template file is read that has all this information in it, there's a directory that contains a whole bunch of local of transforms that can be applied locally. So in this case, probably a fairly common scenario might be that the addition of an authentication key for your Esmond archiver. In this case, let's say, for example, that every host gets a different key. You don't want to have it. You don't want to have to generate a template file that's unique to each host. It's much easier just to distribute it without the key in it and have the host install its own key. So this might be a little piece of what's in the template file. In this case, it's the archive section that defines something called example archive central, and it uses the Esmond archiver. It has some data that goes with it, and it's got a URL for where it goes, and it has a measurement agent. The thing with the braces and the percent signs is actually a special substitution thing that's part of psconfig for filling in certain values. So in order to take that and add, in this case, we wanted to add something called auth token with an underscore to the archive data that we looked at. The first thing we want to do is we want to see if there is actually an example archive central in there. If there isn't, we just pass through and leave it alone. But if there is, then we go through and we go down into archives, we go down to example archive central data, and we assign a thing called auth token. And that's we just assign the value to it, and you get you get this whole big long string that is the token. I can't remember. Yeah, I didn't show output here, but essentially what you would see is, going back to this, you'd see something in data that has the authentication token that's added locally. So I think at that point I've probably stuffed your brains pretty tight with a lot of new material. So we'll take a few minutes here and we'll take some questions and answers. As always, if you have questions on this even after we're done here, please drop a line either to us, the developers, perfSONAR developer at internet2.edu, or you can drop a line to the user list, perfSONAR user at internet2.edu.